Hey everyone, welcome to Haskell for Ada. Today we're going to compare the differences between Haskell and an object-oriented programming language like Python or JavaScript. So one of the unique characteristics, or one of the things that makes Haskell so different from an object-oriented programming language is that it's lazy. So what does that mean? Well, I want to start off with showing you an example with JavaScript. So here we've defined a JavaScript function called complicated function. This complicated function accepts two arguments, y and x. Y defaults to the value of 5 and x evaluates to whatever this expression is. Notice that in the body of this complicated function, we only care about the y value, right? About the y argument being passed in. We don't do anything with the x. The thing is that behind the scenes, JavaScript is still going to evaluate this expression, right? We're not doing anything with it, so it's almost like lost work. Why are we doing more work than we need to if we do nothing with this value, right? So that's, as you can see, if when you're dealing with large amounts of data, that could be wasted resources on your machine. Compare that to a programming language like Haskell, and we'll write the same function in the GHCI in the REPL. So let's go over here and let's start G. We'll clear everything out. Let's do GHCI. Okay. And what we can do is I have some notes here. I can copy that. Let's do that. Okay, so just to kind of give you an idea of what's going on here, although we haven't really talked too much about how to create functions in Haskell, we can just describe what's going on here really quick. So here we've named a function called complicated function, much like how we did in CodePen over here, right? This function accepts two arguments, x and y, and here we only care about x, right, in the body of the function. We want to show it back to us in the REPL, and we basically just want to return this value of x. Okay, so if we hit enter here, we can now use this function, complicated function, and much like how we complicated function 5, right, that's what we passed in here, and we can do y is equal to some large number. Right, and again, we only show 5 because we only care about that x value, right? Oh, you know what we can do? I didn't even define an expression here. Let's do this and this. Oh, I forgot to add the parentheses to evaluate correctly. There you go. And then notice that we only get 5 back. In Haskell, this never gets evaluated, right? We're not doing anything with it in the function. We only care about x. So this expression here, this math calculation never happens. We only get our 5 back because that's the only thing we care about in the body of our function. Okay. So one of the other things that makes Haskell makes it different than an object-oriented programming language like Python or JavaScript. We can see that if we comment that out and we scroll a little bit up to the top. And we'll focus on this right now. Notice how we get 6, right? Basically all this loop is doing is it's multiplying all the items in this array. So if we have an array.length, basically if we pass in an empty array, it's going to throw an error, can't loop over an empty list. Great. If that's not the case, then we'll loop over the list and we'll mutate answer array is equal to array I times whatever answer is at that time, and we'll console.log the answer out. Okay, notice that we've changed a value outside of the function, right? This global variable. In Haskell, you can't do that. So, let me show you what I mean. Let's say, sorry, let's go here and here. So one of the things you can't do with Haskell that you can do with an object-oriented programming language like JavaScript is redefine a variable to equal something new. So for example here we have this function called loop and it equals x, right? What we can't do is say x is going to equal this new value of 6, right? In hopes that this variable here changes to the new number 6 as specified here in our function body. Notice that in JavaScript, right, we can do that. And you know what? Let me take off this screen shader here. There you go. Okay, notice that we can do that, right? Here we're affecting this variable of answer. Answer is equal to 1. And on each iteration of the loop, we're changing the, basically, we're changing the value of our variable answer. In Haskell, we can't do that. What we can do, though, is we can use that variable that's been defined up here, 5, and we can say add another 5 onto it, right? And so let's execute that file. So what we can do is let's quit out of it and let's clear our terminal and let's do GHCI and we'll load. So I hit common L or colon L, and then what's the script called? It's called global.hs. Okay, so we'll do global.hs. Okay, it looks like it compiled correctly. So if we just call our function loop, we get the value of 10. So how did we get the value of 10? Well, let's go back to our script. Notice that here we're using our variable x that's been defined and initialized up here, and we're just adding another integer, which just happens to be 5, right? So 5 plus 5 is equal to 10, right? And again, with JavaScript, you can basically redefine, we can mutate answer, and make it equal to something completely new. Obviously, in this example here, right, it's not too difficult to track down when answer or how answer is being modified. And when I say answer, I'm talking about the variable, right? But let's say we added 5 other functions, right, that also somehow mutated our answer variable up here. Well, now, right, this can become a huge headache when dealing with larger scripts, because now you have to find out when answer is being mutated, where it's being mutated, and it's just going to be a really pain in the butt to track down any bugs you might encounter along the way. With Haskell, again, you don't have that issue. Now, the other thing that makes Haskell unique compared to like JavaScript or Python or any other object-oriented languages is that with those languages you usually have some sort of for loop to iterate over a list of items, right? In this case we have this for loop, and upon each iteration we increase I by 1, and due to this we get to access those items in our array. With Haskell we don't use for loops. What we use is recursion. And here, let me copy this, and we'll go specify it down here, and we'll make sure to correct the indentation. There you go. So here we have this Mult function, and we're not going to talk about this specific line for right now, so I'll just delete it. That'll come up in future videos. But essentially, we have this Mult function. If we pass in an empty list, we get this error that this is an empty list. If there's only one item on that list, we're going to return that item. And here in this specific line, this is where we call the recursion, right? And essentially, this 3 lines of code is equivalent to what you see in my CodePen example here, right? This. Now, it's a little bit more concise, it's a little bit smaller, there isn't so much being specified. So for example, and by that I mean right here we're telling the machine, alright, increase the variable I by 1, what to loop over, where to start, etc., etc. With Haskell, we specify the conditions and what we want to happen upon those conditions. So here we want to execute recursion. Here, if there's only one list item, just give me back that one item. And here we produce an error if an empty list is being passed in. So much like the SQL query language for, databases, right? When we specify like a query in SQL, we're we don't really care how it gets the records back, from the database. We just do the correct syntax, we execute the query, and we get some database records back. It's kind of similar to what Haskell does, right? We don't really care what I is at any certain point. We just specify the syntax, we specify the edge condition where, let's say, the recursion needs to stop at this point, and then execute these two things you know, when you're done, like finishing the recursion step. It's very declarative, where with JavaScript it's very imperative. You're really close to what the machine is doing. You're declaring the variables of I. You're keeping track of the list. With Haskell, it's more declarative. You just tell the machine, hey, I don't care how you do it, just do it. And upon these conditions, execute this code. So that's it for this video. If you found this video helpful, you can find my Ada wallet address in the description below. Please don't forget to join the Discord channel if you need any help setting this environment up on your machine. There's an installation video that I've already coded that you can find on my channel. Alright everyone,